All right, everyone, we're back to do some more problems with section 1.2. What this section called? This section is called, not note-taking with vocabulary, this section is called Solving Multi-Step Equations. So there's quite a bit of a ramp up in the problems, so we're going to take it slow. And number one here, 3x plus 4, you can probably see that I wrote that over here, 3x plus 4. And what I'm going to do is I'm going to give you the reasoning why I'm doing certain things. And, okay, that looks better. So I said in the last video that you need to kind of isolate the terms, or you have to figure out what the terms are. Now this term right here, the 3x, that's our linear term. And I can tell because it has the variable x. Over here, the plus 4, that's our constant term. And that's everything on the left side of the equal sign. On the right side of the equal sign, we have a 19. So it's important that, at least for this section, all of the variables are going to be on the same side of the equal sign. Either they're all going to be on the left or they're all going to be on the right. This one, it happens to be all on the left, and that's pretty standard. This is a pretty classic setup. This is kind of the setup that we want to get our problems in. We have the linear term plus a constant equals another constant. That's kind of where we want to get to. And the next thing that we would do here is we would take that constant plus 4 and then we'd make a zero pair. We would do that by subtracting 4 from both sides of the equal sign. Now when we do that, that's called the subtraction property. And as we're doing this, I kind of want to also remind you that you don't really have to do the right side here. I'm just leaving this here for you so you know that what we did to solve this problem. So we start with the problem that was given, and then we use the subtraction property to make a zero pair with the constant. Okay, so here's our zero pair right here. All that's going to just turn into 0. Now when we do that on the left side, we just get left with a 3x because of course our zero pair makes a 0. So 3x plus 0 is just 3x. Now here on the right side, what we're simplifying, what we do is we do 19 minus 4, and that's 15. So we think of the left side, we do all the math on the left side, and then we do the math on the right side separately. So we've simplified now. Now the next step to do is to divide by the constant that's multiplying our variable. We call that our coefficient. Here's our coefficient, it's a 3. So we need to divide by 3. So here now you can see we've divided by 3, and I'll remind you again that here in algebra, whenever we want to divide, we're going to multiply by a reciprocal. So 1/3 is the same thing as divide by 3. So 1/3 times 3x, of course, that creates our multiplicative inverse right here with the 1/3 and the 3x. And that's just going to give me a 1, which is the goal here. On the right side, when we do 15 divided by 3, we just get a 5. And so the resulting equation here is x equals 5, and that is a simplification because we just did all the division. Remind you again, this right side here are the reasons. You don't really need to do this, you just need to make sure you do the math. I'm giving you the reasons here so you know why we're doing what we're doing. So there's our number one. The solution here is x equals 5. Let's move on to question 4 here, and let's get to it. Question 4 I have right here. We've got mathematics and reasons again. Now with number 4, we again see that we have the variable d on the right side of the equal sign, and we have no variable on the left side of the equal sign. But over here on the right side, we don't have just the 2 terms. We actually have 3 terms. We have a 2 plus a 4 minus a 1d. So with 3 terms here, we could probably do some simplification. And if we classify things, again, we see the positive 2 is a constant, positive 4 is a constant, minus d is linear. So the 2 constant things we can actually simplify. 2 plus 4 is 6, of course. And that brings me to the next major point here. Before we do any of the algebra stuff, we want to do all the arithmetic to simplify the left side and the right side of the equal sign. So that's kind of the background lesson of this problem. Now the rest of this is kind of similar to what we did before. We have our constant term, 6, and we have our linear term, -1 multiplied by d. We'll subtract 6 from both sides of the equal sign. Simplify. Now we could think of the right side as -1 multiplied by d, in which case we would divide both sides by -1. That would look kind of like this. We're going to multiply both sides by the reciprocal of -1, which is 1 over -1, to give me -9 is equal to d. So that's our question 4. Again, the lesson here is simplify the left and the right before you do any algebra. And you can see over here with number 3, you can simplify the right side here. Z minus -9, that's the same thing as z plus 9. Then you just go ahead and do your algebra. Now we're going to do both numbers 5 and 6 because these are different ways of approaching a division. Now if you take a look at number 5, we got just the f divided by 4 minus 5. And then over on the number 6, you've got this q plus -5. This entire left side is divided by 3. So these are two different styles of division, or two different things that could happen. So we really need to take a look at both of them. So let's start by looking at number 5. Now with number 5, we have actually something similar to the problems that we just did, in that we have 2 terms on the left and 1 term on the right. And the thing I want to focus on here is the fact that we do have 2 terms. We've got this f over 4 term, we've got this -5 term on the left side. So really this isn't much different than what we did before, except that we have that fraction over there, that f over 4. Now I don't want to approach that like it's actually f over 4. The way that I actually want to look at that as 1/4 f minus 5. Now I like this better because now we have a coefficient here in front of our variable, which is right in line with all the stuff that we have been doing already. We have that 2 terms, coefficient multiplied by variable, minus constant equals -9. So we can do pretty much exactly the same things that we have been doing up until this point. We're going to make a 0 pair with a -5. We can do that just by adding 5 to both sides of the equal sign. When you simplify, you get 1/4 f equals -4. Again, with this -9 plus 5, if you don't want to, or if somehow that arithmetic is difficult, just use a calculator. No one really cares. But what to do now is to take a look at this. Just like before, we have a coefficient in front of our variable, and we're going to multiply both sides by the reciprocal of our coefficient. Now it just so happens that our coefficient is 1 over 4, and the reciprocal of that is just 4 over 1. So we're going to multiply both sides by 4 over 1. Now remember what happens here on the left side. When we multiply 2 reciprocals, we just get a 1, literally the value 1, and so the left side becomes 1 multiplied by f, or just f. And then the right side, 4 over 1 multiplied by -4. That's the same thing as 4 times -4, or -16. Use a calculator, I don't care, doesn't matter to me. So we get f equals -16. So that's what our number 5 looks like. Moving on to number 6, I can see this is going to be a little bit different because I only technically have 1 term on the left side, and 1 term on the right side. So how is that going to change things? Now maybe the first thing I should address is, why am I saying that there's only one term on the left side? And why I'm saying that is because the only plus sign is in the numerator. So outside of the numerator, there's no plus sign. Like if I put over here plus 9, now we're looking at two terms. We have this fractional term here, and then we have the plus 9. But without that plus 9, we just have one term on the left and one term on the right. And it happens that the term on the left has a denominator of 3. So what we're going to do is we're going to multiply by the reciprocal of that denominator. So we're going to multiply by 3 over 1. Actually, it's not the reciprocal of the denominator. It's just we're multiplying by the denominator itself. So if the denominator of the left side is 3, we're going to multiply everything by 3. Now what that's going to do on the left side is, once I multiply this 3 over 1 really, with this thing with a 3 on the denominator, they're actually going to create a multiplicative inverse. So I'm going to get a 1, and the way that most students would say this is they're going to cancel out. And so what I'm left with on the left side is just q plus -5 equals 24. 24 again is 3 times 8. Now I don't like this q plus a -5. Whenever I have two signs here that are opposite, I can always change it with a negative sign. So that's what I'm going to do. I'm going to simplify that. And I'm just going to write q minus 5 equals 24. You probably didn't have to do these in 2 steps. I mean, I certainly would have felt comfortable if you, on this line right here, if you had just written q minus 5 equals 24, that's fine also. Now this looks exactly like our, the way that we want things to look. We have a linear term plus a constant term equals another constant. So I'm going to create that 0 pair with the constant. And that gets me to q equals 29. Now in front of the q, the coefficient of q is 1. So you might say, well, why don't I just divide by 1 now? And well, there's never any need to divide by -1, because you're just going to get the same thing all over again. So q is in fact equal to 29, and this is actually finished. So we'll put that question number 6 in place, and then we're going to take a look at question 8. Now you're going to notice that question 8 is similar to question 7. It's similar to question 9, and it's also similar to question 10. So you can do all 4 of these with the same technique. So let's take a look at question 8, and then you can do those other 3 in a very similar fashion. Now with question 8, I'm taking a look at the left side, and I see 1, 2, 3 terms. And I can also classify them. This first term here, 5z, that is linear. -2z, that's also linear. And -4, that's constant. So I'm going to combine like terms here, and that's really the only trick here. What makes this a little bit different here is that the terms that I'm combining are the linear terms, are the terms with the variable. So let's combine that. If I had 5z's, okay, there's 5z's, 1, 2, 3, 4, 5, and I take away 2 of them. Boom. How many z's do I have left? And I think it's pretty clear that you're going to have 3 z's left over. And a simple exercise like that is all that's really needed for most people to really grasp what's going on when we're adding and subtracting variables together. So 5z's, literally put 5z's on your paper. -2z, literally just cross them out, or delete them all together, and you can see that we have 3 z's left over. Now this looks a lot like, this is the problem where I want it to be. Linear term plus constant equals another constant. So we'll just do this really quickly with the 0 pair first. And then we'll divide by 3, the coefficient. And that gets me to z equals -1. Putting that in its place, again, number 7, number 9, and number 10, you're going to do in pretty much the exact same way as you did number 8. Number 12 and number 13 both show something new, something we haven't seen before, and that's the idea of distribution. So let's take a look at number 12. So hopefully you've been introduced to distribution already. If you haven't, I just want to remind you that whenever you see a number multiplying a parenthesis, like this one is, then you could just take that number and multiply it by everything inside the parenthesis. So I'll show you what that means. We've got a -4, and that's going to multiply both this z and this -12. That's the way that distribution works. Oftentimes you'll see people when they distribute, you'll see them draw arrows like this. You'll see me do this too. And that just means I'm going to take that -4 and I'm going to multiply it by z. I'm going to take that -4. I'm also going to multiply that by 12. And then I'm just going to put it together. Now, a lot of times with distribution, you wouldn't write this second line that I wrote here. Right, this one right here, you wouldn't write that. You would just simplify that and distribute all in the same step. But since this might be the first time you're seeing distribution, I'm going to go ahead and distribute and then simplify in different steps. So you can see what I've done here. -4 times z is -4z minus, now this minus here is the same as this minus here. Those are the same minus signs. Then over here I've got -4 times 12, and that's -48. So it's really important that you keep track of those negative signs. Nothing's going to make a average algebra student, a poor algebra student, faster than failing to keep track of those negative signs. Okay, so that's the simplification. I noticed there's actually another simplification we can do here. If I subtract something negative, that's the same thing as adding something positive. So this is equivalent to -4z plus 48. Now again, once you get more advanced here, you can go from this first step here that I've highlighted, and the next step that you would write would be this one over here, plus 48. All of this stuff in between, lines 2 and line 3, those are all just learning steps. Those are our training wheels, if you will. Okay, and from here, this looks the same thing like we always did, like we always have. This is a linear term with a coefficient of 4, -4, that is. This is our constant term, 48, and that's equal to a constant. So we'll just speed through this really quickly. 42 minus 48 is negative 6. Again, if that bothers you, go ahead and, or if that's not something you could do in your head, you don't have to. Grab a calculator and do that arithmetic. Multiply by the reciprocal of the coefficient. And that brings me to z equals 3 over 2, which is 1.5. Use that calculator, get that 1.5, and that's what we do here. Just do that distribution and you're going to be good. Now 13, that's another distribution, and hopefully you can see where the distribution is. It's right over here. We've got that negative 3 multiplied by 9 minus r. Now before I can do the distribution, I do want to approach this a little bit differently. Now minus signs in algebra really should make you nervous, and if they don't make you nervous, you really need to learn to be nervous every time you see that negative sign, and you got to take extra care to make sure that you do something correct with it. Now I say that I've simplified, but really I kind of made this more complicated, and you'll notice what I did right over here. I changed this minus sign into plus, and then I've changed the 3 into a negative 3. And I did that because it'll going to be easier for us to distribute. So let's go ahead and we'll do this slowly. So I've kind of written half of this expression here, and I want to distribute. So I'm going to do this negative 3 multiplied by 9. How much is negative 3 times 9? Okay, it's negative 27. Now, notice that over here we have a minus sign. So I'm going to preserve that. I'm going to keep that minus sign. I'm going to put a minus right here next. And then to complete the distribution, I'm going to do negative 3 multiplied by r. How much is negative 3 multiplied by r? Well, it's negative 3r. So that's the distribution step. We did this a little bit quicker than we did in the previous example. I'm looking at this and I see two places where I can simplify. I'm adding a negative number, which is just the same thing as subtracting. And I'm also subtracting a negative number, which is just the same thing as adding. So when I simplify, I can see that this plus and minus, plus a negative number, is the same thing as subtracting. And then I can also see that adding a negative number is just the same thing, or subtracting a negative number, that's just the same thing as addition. So that's a lot of simplification that we're doing here on the right side, and we're not even finished, because over here I've got a linear term, and then I have a constant term, minus 27, followed by another linear term, plus 3r. So if I were to write those out, I would write down 12 r's. Let's write down 12 r's. 1, 2, 3, 4, 12 r's. And then to that, I'd add 3 r's. So how many r's is that total? Right, that's just 15 r's. Okay, 33 equals 15r minus 27. This is the form that we want, because this is going to hopefully be automatic after a while. So we're going to deal with a constant, and then we're going to divide by the reciprocal. Sorry, we're going to divide by the coefficient. So let's deal with the constant term. Then our coefficient is 15, so we'll multiply both sides by 1 over 15. And boom, r is equal to 4. Or I guess it says 4 equals r, but that's the same thing as saying r equals 4. So there's our number 13, probably the most intense problem that we've done so far. And I'd like to point out to you that number 11 and 14 are all distribution problems. You're going to do number 11 a lot like you did number 12, and you're going to do number 14 a lot like you did number 13. Now, the big difference here between 13 and 14 here is for 14, you're just going to distribute a positive 3. You don't have that minus sign in front. It's not a minus a 3, it's just a plus a 3. So you don't have to do this simplification step like we did over here. So that's our number 14. So let's take a look at our real life problems. We've got you can represent an odd integer with the expression 2n plus 1, where n is any integer. So you want to write and solve an equation to find 3 consecutive odd integers that have a sum of 63. So let's think about that. How do we do 3 consecutive odd integers? Well, what's my first odd integer? And it's going to be 2n plus 1. That's an odd integer. And that was the hint that they just gave us. Now the next odd integer, well, let's see. If my odd integers are 1, 3, 5, 7, 9. And to get to the next odd integer, I just need to add 2 to the previous one to get to the next one. So the next odd integer is going to be 2n plus 1 plus 2. So it's the previous odd integer, 2n plus 1, plus another 2. And then what's the odd integer after that? Well, instead of adding 2, I'm going to have to add 4. Because if you take a look, if I go from 1 to 5, that's plus 4. So here's my 3 consecutive odd integers. And when I add them together, I'm supposed to get 63. So let's work on this math problem. I'm going to go ahead and not do the reasons here. Let's first, we don't need these parentheses because in between the parentheses are plus signs. So we'll just go ahead and, when I was in high school, I said, let's just open up all the parentheses. So that's what we do. We're going to open up all the parentheses. And then we're going to take a look at the like terms, starting with the linear terms, 2n plus 2n plus another 2n. So if I'm reading that right, that's 2 plus 2 plus 2. That's 6 n's. And then we'll look at the constant term, plus 1 plus 1 plus 2 plus 1 plus 4. How many is that? 1, 2, 3, 4, 5. 5 and 4 is 9. So this is 6n plus 9 equals 63. Now this looks a lot like the problems that we did just now. So we got 6n plus 9. We're going to minus 9 from both sides. That means that 6n is equal to, how much is this? 54. And then we're going to divide both sides by 6. And that tells me n equals, I think that's 9, right? 6 times 9 is 54. Yeah, n equals 9. So that's great. If n equals 9, just is to write and solve. So that's what we got. We wrote an equation, and we solved the equation. N equals 9. 16 is a little bit of review from what we did last time. We've got one angle of a triangle has a measure of 66 degrees, and the measure of the third angle is 57 more than half the second angle. The sum of the angles in the triangle is 180. what's the measure of the second angle, and what's the measure of the third angle. Okay, so let's write this down. The first angle is 66. The second angle we don't know, so we'll make that x. And the third angle is 57 more than, so we're going to add 57 to half of the second angle. And the second angle, remember, was x. So those are the three angles. And if I add them together, I should get 180. So remember, we did angle sums of polygons earlier. So this is really more of the same. Okay, just like the last time, I've got parentheses that have plus signs in between them, which means I don't really need them. So I'll just open that all up. Like every other algebra equation we do, we're going to combine like terms. Plus x and a plus a 1/2 x. That is 3/2 x, or 1.5x if you want. And then for the constant terms, I have a positive 66 and a positive 57. So how much is that? Well, that's 123. So this puts me in the form that I like best: constant or coefficient multiplied by variable plus constant equals another constant. So we're going to do pretty much the exact same thing that we always do. We're going to make our zero pair with our constant. And this time I'm going to do that in red, minus 123. And that's equal to 180 minus 123. Make that zero pair, and 3/2 x equals 57. That's 57, so now we have 3/2 x equals 57. We're going to multiply by the reciprocal for our quote-unquote division. So we'll multiply both sides by 2/3. Go ahead and ask your Alexa, ask Google, do whatever you need to do this multiplication here, 2/3 times 57. And that's going to give me 38 for x. Okay, x was the second angle, so the second angle is equal to 38. And then for the measure of the third angle, well, the third angle was half of the second angle plus 57. So what's half of 38? That's 19. 19 plus 57. So that third angle is 76 degrees, and that does it for us today. Hey, that was kind of a long one, but we did a lot of really good examples here. And this is kind of the bedrock of our algebra skills. So the more time we spend here, the more you focus on these problems, the easier the rest of algebra is going to be. Trust me, put in the work now, and the rest of algebra will be so much easier. So I'll see you guys next time. Have a good one.